All right, so let's look at problem number 17. This one's worded a little bit different. Got a man holding the gun over his head at a height of 200 meters. So the way this one is worded is a little confusing. So here's how I took this to be, and that's why, once again, why I like to draw a diagram. So basically, the gun is already at a height of 200 meters. So we already have a y displacement. Whether the guy's floating in the air, or I like to think about it as like the guy's on top of a 200-meter high cliff. So the gun is already 200 meters above the ground, whether he's on top of a building or he's just got really obscenely long arms. The gun is at a height of 200 meters when it is fired. He fires the gun and shoots it straight up in the air. But the bullet gets to a final height of 1,000 meters above the ground. Okay, that means from where he fired it, it went up 800 more meters because it was already 200 meters up. This is going to be 800 meters. Okay, still the same things we know here. Velocity in the y up there is 0. What is the initial velocity of the bullet? Okay, so for this, we're here A. I want an initial velocity. Now, this has nothing to do with velocity. Oh, this has an initial velocity in it. If we knew a velocity and we want to find the initial velocity, if we know an acceleration, which we do, and we knew a time, we don't know a time. We don't know how long it takes the bullet to get to the highest point. So we can't use that to find the initial velocity. Let's come down here. A change in y, we know it goes up 800. We know the acceleration is gravity. Once again, we don't know the time. So let's come down here and check this one. A velocity in the y direction. Well, we do know that up here is 0. We know an acceleration. We know the displacement in the y direction is 800. So we can use that to find the initial y velocity. So I'm gonna plug the numbers in there. At what point we're talking about the y velocity? Even though the y velocity is actually, here's what I'll do. I will rearrange the expression first. I want to isolate this, get that equals something else is going to be. All I did was move this stuff over to this side to get the variable I want by itself. Okay. What y velocity am I talking about? The 0 at the highest point. How much did the y change? 800 meters. Now, I've got to take the square root of whatever that expression is. Got a negative, so it's going to be a positive. Square root of 15696 meters per second. Meters squared per second squared. Take the square root. We get. Okay. Now keep in mind, I like this. And remember, a velocity, when I take the square root, I'm going to get a positive or a negative in it. It's plus or minus. The question is, which one is it here? If we assume that down is the negative direction, the initial velocity was going up. So I'm going to choose the positive value. Keep in mind, he could have been on top of that cliff and firing the gun down, in which case we would have to choose the negative value. So the sign does matter because it tells you which direction that quantity is working in. All right, what is the velocity of the bullet when it hits the ground? Okay, so I want the velocity right here. Okay, there's a couple of ways we can think about this. And this is the great thing about physics problems. There's more than one way to skin a cat, so to speak. For those you've never heard that expression, I apologize. I'm old. I use old expressions like that. Okay. Now, so what do I know here? I can't do that same thing I did in the last problem. I can't say that the final velocity is the same as the starting velocity because it hasn't come back to the same point. Okay. I do know right here that the velocity is that, because remember, if it starts here, when it gets back to its same point, the velocity right there is negative 125. I do know delta y from that point would be 200. So I could maybe use those expressions there. I want to know what was the velocity when it hit the ground. I want a y velocity. Y velocity. An initial velocity, an acceleration, a time. Well, from here to here, I don't know a time, so I can't use that. Do I know the total change in the y displacement? Actually, I do. I do know from here going up and coming down, its total change when it was all said and done was 200. So I can maybe use that because I know the acceleration. I'm stuck with time again. I don't have the time. Let's look at this. That's what I want to find. The acceleration in the y when it hits the ground. Do I know the acceleration? Yes. Do I know a change in y? Sure, I know all of the y values. Do I know an initial velocity for y? I do, because I just solved for it. I figured out what the velocity was as it came out of the gun. Okay, so now I've got enough here. So I'm going to go B. So now the only question is, well, where do I pull these numbers from? Okay, well, remember I said we draw the diagram. Let's see here. I always like using this highest point because I know something about it. I know that the velocity at that point is 0. And zeros in my mathematical equations work out good because they just kind of like take an expression out. So let's look at it from here to here. My change in y would be 1,000 because that's how far it totally moves in the y. I know the initial velocity is 0. And I know the acceleration over that whole time is negative 9.8 meters per second squared. So that might be good. It moves 1,000 meters. I'm putting in 0 there because I like it from this point where y is 0. Now I do the math. I'm going to get a square root number again because I'm going to square underneath here. 19,620. Remember, I'm going to get a positive or a negative. Okay, so it's 40 meters per second here. So which one should I choose? Should I choose the positive or the negative value here? Well, it's now going that direction, so I'm going to have to choose the negative of those numbers because I know it's now moving in the negative direction. Now for part C, the how long is the bullet in the air? Now this is the same as the last problem, and so there's two different ways we can do it. We can work this doing the quadratic formula, where we use this formula here for C. Come up here. We're going to use, I'm sorry, we won't need the quadratic formula. Yeah, we will on this one. If we use because we're going to get t in two expressions here. And when we solve this, we're going to get, using the quadratic for t equals minus 125 plus or minus the square root of 125 squared minus 4 Okay, so let that sink in a second. So where did these numbers come from? Well, my change in y over the whole motion was only 200 because it started here and finished 200 meters lower than it started. We already calculated the initial velocity was 125, and there's my acceleration due to gravity. So I solve this, and after I do the quadratic formula, I get negative 1.5 seconds or 26.9 seconds. Well, you can't have a negative time for this occurrence to happen. So you definitely know it's not that. It's got to be positive 26.9 seconds. Now, if you are not comfortable with the quadratic formula, but you're okay with some of the other math problems, we could do this a little bit different way. We could actually calculate the time over a couple of the different segments and then just combine them. And I'll show you that too. So with this one here, time to go up from 125 meters per second to 0, it's over 800. So let's find me an easy expression. I know a velocity at that point would be 0. I know the initial velocity is 125. I know the acceleration. I could use this expression here to solve for the time from here to here, which I know is the same as the time from here to here. So I'm going to do it that way. I'm going to go velocity in the y, initial velocity y, plus at. So the velocity in the y at the highest point is 0, 125 positive because it's going up. So now I can solve this. Time equals negative 125 divided by negative 9.81. Notice negative is going to give me a positive value for my time, which makes sense. So when I do that math, I get 12.7 seconds to go up to that point, which means it also takes 12.7 seconds to come down. That gives me about 25.5 seconds for the trip from here up and back down again. But I need the time for the whole trip. So the question now becomes, can I figure out the time from here to here and combine it with that? Well, I can probably use the same formula. Do I know a speed? Do I know a y velocity here? Yeah, I solved for it. It was 140. Do I know the initial speed from here to here? Yeah, it's negative 125. Do I know the acceleration? I do, because it's caused by gravity. So I can go dy so from here to here, my final y velocity was negative 140. My initial y velocity was negative 125. Mine a. So time, when you solve for time, it becomes negative 140 plus 125 divided by 9.81, or time equals about 1.5 seconds from here to here. Well, add that to my time for the other section of 25.5, and I get which when I did the quadratic formula, I got 26.9 Notice it's the same. All right, so very commonly with physics problems, there's going to be more than one way you can do it. And if you can figure it out one way, that's great. Apply those formulas and find out the other way, different formulas, it's all the same.